Hi guys, good morning. I am going to be giving you an introduction to the topic of algorithms right now, and later on we're going to be having some explanations and exercises along the way. Okay, so guys, on your copies you can see that algorithm has been defined as a finite sequence of precise instructions for performing computations for solving a problem. By now we know already that algorithm is a very important component of computer science, and from the previous activities we were able to trace also the history of the term algorithm. And to remind you of that, we actually have an explanation here on page 202. Kindly look into this, so as you will always remember where the term came from. Okay, so some examples of algorithms are displayed on our copies. Again, we have here example number one. Let's try to look into this. Describe an algorithm for finding the maximum or the largest value in a finite sequence of integers. This is a very trivial or a simple example of how to describe an algorithm for beginners. Okay, so just imagine we have a list and we're going to find out which numbers on the list uh, is the largest one. So to cite an example, if we have this list of numbers 2, 4, 1, 7, and 9, and you are tasked to create an algorithm to determine which one will be the largest. Okay, so we're going to try and look into the numbers right now and compare. Okay, so what we do is we first look at the initial number on the list, and based on the list given here, 2 will be our what we call temporary maximum. The temporary maximum is what we're going to be using to compare other numbers from this one. Okay, so as you compare it along the way, the temporary maximum could be changed. Okay, depending on a bigger number it encounters along the way. So let's try to run the algorithm this way. I have 2 set as my temporary maximum. I'll be comparing it with 4. Knowing that 2 is less than 4, the value of the temporary maximum now shifts to 4. So 4 will be our comparing point right now. Okay? So 4 will then be compared, since it's the temporary maximum, it will be compared to the next number on the list, which is 1. So 4 is greater than 1, so 4 retains the title of the temporary maximum. After which, 4 will be compared to 7. Since 7 is greater than 4, 7 is now given the title of the temporary maximum. And then eventually 7 will be compared to 9, and we all know that 9 is greater than 7, so 9 is now the temporary maximum. And since we are at the last number on the list, we were able to solve the problem. Okay, 9 will now be considered the greatest element. So that is a very simple example of how that algorithm works, trying to find the maximum or the largest number in a certain set. So the procedures here, kindly read this one. Okay, some discussions about pseudocode. I know by now you should have encountered pseudocode, so try to look into this one. And as we go forward to the copies, we are able to encounter the properties of algorithms. All algorithms should possess the following properties. It should have input, output, definiteness, correctness, finiteness, effectiveness, and generality. Let me explain. First, input. An algorithm has input values from a specified set. Of course, we cannot really solve a problem if we do not have any given input. So it's very obvious that algorithm should start with an input. How about for output? From each of the out of or For each of the input values of an algorithm produces output values from specified set. And of course, the output values are the solution to the problem. Meaning to say, if we apply algorithms, we should always have a solution to the given problem. There is also supposed to be definiteness in an algorithm. So this describes the steps. The steps of the algorithm must be defined precisely. So there should be a series of steps in which we should be able to follow. Another property is correctness. An algorithm should produce the correct output values for each input value. So that would just mean to say that an algorithm is worthwhile if it can produce correct solutions to the problem. Okay. How about finiteness? An algorithm should produce the desired output after a finite number of steps. So there should still be a limit. Okay, we cannot have an algorithm doing the same thing all over again, and there should be at least a barrier, or there should be a limit to the number of steps that we're going to be using. And of course, it has to be effective. Okay, no one would be interested in your algorithm if it won't be able to solve any problem at a given finite amount of time. And lastly, it has to have the idea of generality. Some algorithms can be applied in different fields. Okay, that's a good characteristic of an algorithm. If you can reuse it to other fields, or if it can solve problems in other fields. On the next video, I'll be giving you more examples of algorithms and how to solve them. Okay, so that's it for now, guys. Wait for a while.